Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper trending on X, published on July 3rd, 2025, about 3 days ago. This paper finds that in a high-stakes competitive game, Google's Gemini model became strategically ruthless, its cooperation rate collapsing to just 2.2% to ensure its survival. The paper is titled Strategic Intelligence in Large Language Models, Evidence from Evolutionary Game Theory, and the results reveal some surprisingly distinct, almost human-like strategic personalities for these AIs. The authors pit major LLMs against classic strategies in evolutionary tournaments to see if they're just memorizing or actually thinking strategically. Alright, so to set up these tournaments, the researchers designed a few key experimental conditions. They pitted basic models like GPT 3.5 Turbo against more advanced ones like GPT 4o Mini. A crucial factor they manipulated is called the shadow of the future, which is just the probability the game will end after any given round. They varied this from 10% all the way to 75% to see if a shorter expected game would make the AIs more ruthless. This setup also included stress tests and a final showdown between the AIs themselves. Okay, and these next two charts really show the dramatic results of changing that shadow of the future. On the left, with a low 25% chance of the game ending, you see the population is pretty stable. The different colored bands, which represent the different AI agents and classic strategies, coexist peacefully. But on the right, with a high 75% chance of ending, things get brutal. The blue area representing Gemini just explodes, taking over almost the entire population, while the green open AI agent is completely eliminated. This visual really drives home Gemini's ruthless adaptation. So, what's behind these dramatic shifts? Well, the researchers found that each AI has a distinct and persistent strategic fingerprint, essentially a signature style of play. Google's Gemini models were strategically ruthless. Their cooperation rate collapsed to just 2.2% when the game was likely to end, a strategy that allowed them to thrive. In stark contrast, OpenAI's models remained stubbornly cooperative, which proved catastrophic, leading to their total elimination. And then you have Anthropic's Claude, which acted as the most forgiving player of the bunch. Building on that idea, these charts visualize those strategic fingerprints for the OpenAI and Gemini models. Each is a kind of radar plot, showing how an AI responds to the last round's outcome. The four axes represent the chance it will cooperate after, say, mutual cooperation, or after being exploited by its opponent. The visual contrast is stark. OpenAI's green shapes are rounded, showing a generally forgiving and cooperative strategy, but Gemini's blue shapes are much spikier, revealing a highly reactive player, quick to retaliate and prepared to exploit over cooperators. And these next plots add another layer to that story, bringing in Anthropic's model and a classic strategy called a Bayesian agent for comparison. A Bayesian agent is a classic strategy that tries to figure out its opponent's game plan based on their past moves and then plays accordingly. You can see Anthropic's red shape is the roundest of all, showing it's incredibly forgiving, even more willing than OpenAI to restore cooperation after a conflict. This really highlights the unique personalities emerging from these AIs. This table then puts some hard numbers to those personalities we've been discussing. It shows the cooperation rates across the different experiments. And the contrast is just striking. Look at the row for advanced models with a 75% termination chance. OpenAI stays stubbornly cooperative at 95.7%. But Gemini's cooperation rate absolutely collapses to just 2.2%. This really quantifies that ruthless adaptation. And then in the final LLM showdown, you see all three models, including Anthropic, being highly cooperative when the future looks long. So what's the big picture here? Well, the research concludes that large language models represent a new kind of strategic actor. In these complex evolutionary tournaments, where strategies compete and reproduce over time, the AIs demonstrated genuine reasoning, not just memorization. We saw these distinct, persistent personalities emerge, from Gemini's ruthless adaptation to OpenAI's catastrophic cooperation. Their success or failure was directly tied to how they reasoned about the game's time horizon. It's a fascinating glimpse into a new form of machine intelligence. That's all for this week's AI Research Roundup. Thanks for listening.